So we are in week 3 of Phenotype February, and this week is major depressive disorder. But before I go into that, I will say a couple of words about last week. Last week we talked about non-small and small cell lung cancer, and we did all of the steps, literature review, replications of definitions, and on Friday we had a wonderful discussion on the complexity of phenotypes for lung cancer. And one of the things that we discovered is that most of the studies focus not on the broad lung cancer phenotype, but instead on the specific subtypes, which really made our work on analyzing the discrepancies hard. And it was a very nice discussion. So I would encourage you to go into the Teams and check out the recording that is there. Now, we move into the major depression week, and we completed the literature review, and we are moving forward to the replication. We will talk on this call about what we learned so far from the literature review. Then, just to say a couple of words about the next week, the data extraction for pulmonary arterial hypertension is in progress, and then we will follow the same pipeline that you see here. And just to also step back to the week 1, you would have think that we've done everything for Alzheimer's disease because we reviewed the literature, we replicated the cohorts, we characterized the patients, and we even looked at the performance characteristics of those phenotypes with Phebvalidator. But actually, there is something else we can learn, and Jamie Weaver will talk about that.
Thank you. Measurement errors for phenotypes on their own are excellent, and they're really good to know, and we do wish that they were all at 100%. But that's unfortunately not the case. So what we've done is, once we've created all of these phenotypes and generated their measurement errors, we wanted to try to empirically observe the impact of the measurement errors on the background incidence of these phenotypes. To do that, we used a set of inputs, and in this case, we used our 13 Alzheimer's disease definitions, and we built them in 7 databases. And for those 7 databases, Joel Swerdell carried out a Herculean feat of producing sensitivity, specificity, positive predictive value, and negative predictive value for all of these definitions, all stratified by age and sex in these 7 sources. So he gets a World Cup trophy for that. We then characterized the background incidence rate and proportion per 1,000 persons and 1,000 person years, respectively, in those databases. And then to determine the actual impact of the measurement errors, we corrected those background incidence rates using quantitative bias analysis principles. And you can see one long equation here that is a way to adjust the numerator of the incidence rate calculation while incorporating the sensitivity and specificity of the particular definition. So what we ended up with is an uncorrected background incidence rate and a corrected background incidence rate. And we wanted to see what the impact of the sensitivity and specificity was on the change between those two. So we measured the impact using the relative incidence rate, which is the corrected over the uncorrected, and then using this metric called the expected absolute measurement error, which is a directionless linear difference between the two. Next slide. So this is a screenshot from an application that includes all of the results for those 13 definitions in those 7 databases for all of the strata of age by sex for all 13 of those definitions. This messy slide is for the Harris definition, which is 2 diagnoses or 2 prescriptions for Alzheimer's, or 1 diagnosis and 1 prescription. Whereas in all of those cases, the second event needs to happen within a year after the first. So in the Medicare database, the US database, for this Harris definition, we saw that in this particular strata of women over 85 years or older, sensitivity is 70%, and the specificity is 99% that you can see in the upper right corner. There's a great deal of precision with these estimates owing to the phi-evaluator process of evaluating on a large sample from the population. Down in the lower right, you can see that the background incidence rate of this particular Alzheimer's definition was 58 per 1,000 person years. But then after applying that correction that I showed in the last slide, that then increases owing to the 70% sensitivity to 71 per 1,000 person years. And that is a relative difference of 22.8% with an expected absolute measurement error of 0.205. So the again, this is an example of one of those definitions, but when this app gets put up later in this week, you'll be able to review for every single one of our 13 Alzheimer's definitions in those 7 databases, what the background incidence rate is and how it actually, and then what the observed measurement errors, how the degree to which they impact the uncorrected rate. So that's it. This is one example of the impact measurement errors can have on a characterization result. Can you go to the next slide, please? So the technical machinery to run the cohort diagnostics and the background incidence rate is all in this study package, which I've spent a little bit of time developing, and Thomas Falconer has been helping me a great deal with making sure that it runs bug-free outside of my environment at J&J. And so there's a link to that package here, and it includes the study package and a little code, like a how to run script that you would need to follow very much to the T in order to produce these same results against your own data. And there was a survey that went out a couple weeks ago, or last week rather, and 4 data partners have signed up to execute this so far. So I will contact you very shortly, and we'll work together to get this run on your data. Thank you.
Thanks so much, Jamie. You can post any questions, as I would assume you have lots of them in the chat. And as Jamie closed the loop on what you would do once you have phenotype and once you estimated its performance, you can now adjust your estimates based on the phenotype's performance. Given that, it's a good opportunity to now move to the phenotypes for major depressive disorder, and I will talk about what we've learned so far in reviewing the literature. And to give you an overview on what we did, as with the other conditions, we had the initial set of manuscripts that we identified based on the standardized PubMed query. But then we did something different from the other weeks, because Hayden, who was reviewing this pool of manuscripts to identify the initial set for the subsequent scan, came up with the automated scoring mechanism to prioritize the manuscripts based on the words that you see there, and the type of words that you can find in the abstract. And if this is something that you're interested in, I would encourage you to reach out to him to talk about that scoring mechanism more. We then did the usual filtering to arrive at the final set of papers, and we had 24 manuscripts for which we performed data extraction. And of course, we want to thank everybody who performed the data extraction: Tamir, Atif, Jessica, Bill, Bucci, Ruchong, and Septi. Many thanks for picking up this work and really doing an amazing job with the extraction. And as I said that we implemented this unusual, not typical automated scoring mechanism to organize the abstracts and the papers, that actually made us think that there is an opportunity for systematic approaches to literature review to support phenotype development. Because what we will see next is that phenotypes in papers are really different. And if somebody uses the papers to sort of shape the direction in which they will be going with their phenotypes, it's good to make sure that you're including all possible papers on the topic and looking at different perspectives on how people created the phenotypes. And for that, you really need to have some sort of support of machines. So it would be nice to, there is an opportunity to come up with a systematic approach to lit review for phenotype development. That being said, there were a couple of things as we were looking through this 25 papers, there were a couple of things that we thought were interesting. The very first thing is the basic question of when researchers report their phenotypes in the papers, do they aim at really enabling reproducibility of those phenotypes, or do they aim at just describing what those phenotypes are in a conceptual way? And a couple of papers leaned more towards conceptual definition, where they provided some sort of rationale for why they created phenotype in the following manner and the population that they really wanted to capture. So for example, you see a couple of examples on the screen. One of the good examples is the second one, is that researchers wrote in the paper that they excluded, when looking at depression, they excluded the data coming from the hospitals that recorded less than 20 admissions, because the focus of that study was to look at the quality of care for patients with depression. And therefore, they wanted to really focus on the hospitals where they have enough patients hospitalized with depression, and therefore they believe that those hospitals have good protocols for treating depression. So that is a good example, I felt, of the description of the rationale, because now if you have the same rationale, you can think about your own data and how to implement the similar rationale in your own data, knowing how it was captured. So now you don't have to follow what somebody did, but in fact, you can analyze it and implement it in the way that would be tailored to your own data. But then there were bad examples where the authors said nothing about their intent, but then when we looked at the codes, we saw that all of a sudden they excluded some of the codes. Like, for example, they excluded major depressive disorder in full remission, probably because they didn't want to capture patients in remission, and they relied on that code to tell them that patient is in remission. Well, in fact, you can model this in many different ways. So that is a bad example, because there was some sort of rationale, but it was not explicitly stated, but instead you have to infer it from the code selection. So that was just a couple of examples where some of the studies wanted to also provide that idea of what they wanted to capture. But most of the papers didn't do that, which made me think that their descriptions were focused on enabling reproducibility of those phenotypes. So in most of the papers, in 21 out of 24, people put codes. They didn't provide rationale for the selection. Instead, they just provided codes. And in fact, they prefer to put the codes in the body of the manuscript, which makes us think, at least me, that they thought that for the readers, knowing those codes are really essential to getting the gist of the paper, which is sort of arguable, but that probably makes us think that they wanted to have those codes to enable reproducibility of those phenotypes. Then some of the papers didn't have codes, and there was one funny example where the paper just said, we used read codes to define depression, period. You don't have to know which codes, we just used read codes. That should be enough for you. And only 5 out of 24 papers really explicitly stated the list of codes that they used. And of course, it doesn't imply that we can actually reproduce those definitions, but at least if we think that authors wanted somebody to be able to reproduce their definitions, only 5 of the papers made the basic step of explicitly stating the codes. And then the others didn't even do that. That's on the reproducibility. And there were actually 2 Odyssey studies. And funny enough, there was already a difference there. One of the studies that only utilized US data sources provided explicit list of ICD-10-CM and ICD-9-CM codes. And while another study done on US and Korean data sources provided a SNOMED ancestor for depression and said, take the ancestor and all descendants. So we already have here different practices on how to report phenotypes, even in the Odyssey studies, which again opens up an opportunity for systematic reporting and thinking about how we can, standardize the reporting of our phenotypes. And we will also take a glance at the content of the phenotypes themselves. I will just say a couple of words about what we saw so far, and we will have more information once we replicate the cohorts. And if you want to replicate the cohorts in Atlas, there is a sign-up sheet that you can find in the major depressive disorder folder, step 2 cohort replications. But what we saw so far is pretty much the typical things that we see. The common patterns in definitions were using 1 code or 2 codes or 3 codes with various restrictions, different time windows, different positions. So really nothing new. All the usual approaches to making sure that you somehow limit your populations to really patients that have depression. And another common pattern is that, yet again, to make sure that you're really capturing the major depressive disorder, a lot of papers excluded differential diagnoses such as bipolar, dementia, and psychosis. And in terms of the concept sets, really there were, yet again, very common patterns of either including all available ICD codes, and here's an example of ICD-10 codes, such as F32 and all of its kids, or F33 and all of its kids. And then some of the authors felt that they wanted to be more complicated, and they excluded some of the codes that they felt represented certain meanings, like remission. And we will have more discussion on that, of course, once we replicate all of the cohorts. So if you are interested in analysis like this, please stay tuned for the Friday call this week. And as we're going towards the end of this call, we just want to briefly talk about the next steps. And the next steps include progression with the data extraction for pulmonary arterial hypertension. The next step, as we said, for depression is to replicate the cohorts, and you can sign up on the sheet to either replicate them or QC them or learn how to do that. And we will follow with the replication of pulmonary hypertension cohorts. as Jamie talked about the study package, that is also the next step for those who signed up to be data partners. And if you haven't, but this is something you want to consider, please sign up in the teams to be a data partner. And finally, we want to summarize everything we've learned so far and throughout this February in the manuscript. So we will have a call to plan the manuscript as well. And I think I'm right on time, and that gives us an opportunity to answer any questions if there are any in the chat.